If an object rolls off a horizontal table, a height h above the ground with an initially horizontal velocity v, what would be some appropriate expressions for the horizontal and vertical components of the resulting motion? So to start us off with this, I've written down the most general formulas for projectile motion. And the way I look at these two formulas, this is really y as a function of time t. T is the independent variable. So if you wanted to, you could think about this as kind of a function. And just like any function in math class, there could be parameters. And usually in math classes, you're given numbers for those. But in physics class, we're using symbols. Y naught is the initial vertical position. V naught y is the initial vertical velocity or component of velocity. And this minus 1/2 gt squared has to be there because, kind of following what we know about kinematics, if we're describing the vertical component of projectile motion as representing free fall, this has to be there in the vertical component equation. For the horizontal components, we have x as a function of time is equal to initial horizontal position plus initial horizontal component of velocity times time. But again, these are parameters. So really, I think what my task here with this question is to use these formulas and make appropriate replacements based on what's being described and the variables that I've been given to come up with a new and simpler set of formulas that would lend themselves to answering questions about this. So to help me figure that out, I'm going to try to draw a table here. So let me kind of draw some part of a table here. Here's kind of, I don't know, whatever. Table. I'm going to put a leg on that table here. Yeah, okay. And this table might be on, I guess most tables are on the floor, right? So here's the, I didn't draw the rest of it. I mean, there needs to be a leg somewhere else, I guess, but I'm just going to say that's somewhere off the screen. So here's an object that's rolling along, and I think if I look at the description there with the velocity v, the horizontal velocity v, that arrow might represent that horizontal velocity v. It's going to get to the edge over here still with that horizontal velocity v, and that's going to kind of represent where the projectile motion initiates, right? So again, at that moment where it does that, I think it makes sense that it would still have a horizontal velocity v because it hasn't started to fall just yet. And where it does that, the object is basically a height h above the ground. Now I've drawn this object to have also some, like, you know, some width or thickness or radius or whatever. I'm not going to worry about that so much if that adds to h because it wasn't given in the problem statement. So I'm going to pretend this thing maybe is really a point, but that would be hard for me to see. So anyways, this is kind of my picture of this situation. And now I kind of have to ask, like, well, what would some of these parameters equal given this situation? And maybe we can look at a couple things first. Like, I'm going to look at y naught first. And you might say, why did I start with that? So, well, why not, right? I'm just kidding. It's the first one there. It's the parameter that represents, again, the initial vertical position. Now, when I'm given these formulas here, and I'm looking at y as a function of t, and I've got like x's and y's and stuff, I think there's kind of a coordinate system implied, but in physics, we don't always draw our coordinate, but if you don't know what the coordinates are, you're kind of maybe stuck. So I do need to say at least one thing. I want to say, like, where am I going to put my origin that I'm going to look at this situation as sort of a point of reference, right? And I think what I'd like to do is I'd like to put the origin right here underneath where I've called where the initial kind of position or where the projectile motion initiates. I think that's a pretty sensible place to put the origin. So a lot of times I try to be transparent about where my origin is. Physicists will sometimes get a little fast and loose about that, so it's not like it's a requirement that that I or you always do that. As long as you know that it's there and then are consistent with it, that's going to be the important thing. Based on these variables, though, in my picture, I think the initial y value, so where this object is at the point that I'm saying time starts and I'm describing projectile motion now, I think that corresponds to the h that is pictured there. So that's going to let me make the replacement. Y naught is equal to h. Now, what else do I have in this kind of y or vertical component? I've also got v naught y as a parameter there. I'd like to make a replacement for that. But initially, because this really represents the initial vertical component of velocity. But this object just rolled off with just a horizontal velocity. So I think it makes sense that that initial vertical component of velocity is just going to be equal to 0. Let's look at the second equation. What kind of replacements can I make there? Well, x naught is the initial horizontal position relative to the origin. And usually I like to say that this one can always be made to be equal to 0 because you can always just make an appropriate choice of origin. In fact, one could argue that's the reason I chose this origin, is because it makes x not equal to 0. And the more zeros I have, the easier things get for me. So that's why it's good to do that. Let's look at v naught x now and see what we can do with that. Well, we have this v that was given to us, which really is described as the initial horizontal velocity. And this is the horizontal component of the initial velocity. So wouldn't it make sense if that one is equal to v? And so if I make those substitutions into these two formulas, I'm going to get y of t is equal to, let's see, I've got an h. And then this one went to 0, right? I can maybe say plus 0 minus a half gt squared. Why did I say plus 0? Well, v naught y is equal to 0 times t would still be equal to 0. So I could simplify that to just h minus 1/2 gt squared. And that's, that's going to be one of the expressions that I'm giving here. That's really the expression for the vertical component of motion. X of t represents the horizontal component of motion, and making, again, the appropriate substitutions, I've got 0 plus vt, which really means I've just got a simple vt there, which really just represents the rate formula, represents inertia, which is what I would expect. So a couple of very simple formulas there, and maybe I can see them summarized here. For whatever reason on the slide I did the x's first, but it's just x of t is equal to vt, y of t is equal to h minus 1/2 gt squared. You might consider writing these down. These are the two formulas for projectile motion for something that rolls off like a table or any other level surface, has an initial horizontal velocity, and then falls down through some height below that after it's rolled off whatever surface it's rolled off.